Alright, in this video we're going to wrap up the 2.05 lesson on complex roots with a couple more problems, two more problems. Alright, so here again we have a quartic, so the exponents go 4 to 0, so you can treat it like a quadratic. By the way, in the previous video I referred to this x to the fourth as a cubic. That's not a cubic, that's x to the third is a cubic. This is a quartic. But you can treat it like a quadratic. So you're going to have two terms, two binomial terms, and we have to fill that in. Other than that, we treat it just like a quadratic, so we're going to factor it the way that we have in the past. And by the way, we could use the quadratic formula for this, but I'm going to go ahead and factor it and then use the quadratic formula for the imaginary or complex part. That's what the quadratic formula is uniquely good at doing, is dealing with complex roots. But we could use it to factor this as well. Okay, so the coefficient here is a 1, a 3, and then you have a negative 18. So the grand product is 1 times negative 18 is negative 18. So we want this to multiply. Multiply to negative 18, add to 3. Since it's a negative number that we're multiplying to, one of the numbers has to be positive, one has to be negative. And since it adds to a positive number, the bigger of those two has to be positive. So I'm going to start with a small negative and a big positive. Negative 1, positive 18. Okay, multiply those, you get negative 18. Negative 1 plus 18 gives you 17. Okay, not good. We need to get 3. Negative 2 times 9, negative 2 plus 9, that equals 7, so that's not what we're looking for. We're trying to get to negative 3. Negative 3 times 6, and negative 3 plus 6 equals 3. That's what we're looking for. So these are the two numbers we're interested in. Again, since the coefficient here is 1, just x squared, it's just going to be x squared minus 3 and x squared plus 6. And again, if you want to check that, just FOIL it back out and you will get that. All right, so as we look at this, there is a number which squared, because when you square a number you get a positive number. There is a number which when you square it and then subtract 3 will give you 0. And that number would be the square root of 3. So that is actually a real number. It's an irrational number because it goes on forever and ever and ever. It's like 1.71 something goes on forever. So it's an irrational number, but a rational number is still a real number. So you can get a real number out of this. And you can get, but this one you can't. Because if you set this equal to 0, x squared plus 6, it means some number squared plus 6 would equal 0. Well, any number squared, as we've said before, is going to be positive. If you add a positive number to 6, there's no way you can get 0. There's no positive number plus 6 that would equal 0. So this one is going to be imaginary or complex. So to factor this, since this isn't going to be a nice integer value, we're best off using the quadratic formula for both of these. If this had been x squared minus 9, we've done that one many times before, we'd get x plus 3x minus 3. But it's going to be the square root, so it's best to go ahead and use a quadratic formula for that. And by the way, when you get things in these problems that end up with like the square root of 3, you don't have to go to your calculator and figure out what the square root of 3 is. You just leave it as root 3, a square root of 3. Okay? So first we're going to start with this one. And I'm going to write this, remember what I said on the last problem. There's no x term there. So I'm going to write this in this way. X squared plus 0x, because that indicates there's no x term, it's 0, minus 3. So A is the coefficient there, negative 1. B is the coefficient there, which is 0. And C is the coefficient there, which is negative 3. All right, so let's go ahead and plug this in. Again, write the quadratic formula first. And now plug in the numbers. This one's just going to be -0. And I'm going to go just with the plus sign here. Okay, so something you're going to learn to spot here as you get experience with these is if you look inside the square root, I have a -4 times 1 times -3. That's going to give me a positive number. The square root of a positive number is a real number. It's not an imaginary number. Square root of any positive number is an actual real number. So I'm going to end up with a real number here, and that's what we said. This is going to have real roots. It's just not going to have integers, nice integers like we've had in the past. So let me go ahead and finish this out, and that's going to be over 2a, which is just 2 times 1. So that means that this is going to be the square root of 12. That's this. The 0 is 0, the 0 is 0 there. The square root of 12 over 2, which equals, and now this is where we want to factor it out, 2 times 2 times 3. It's a positive 3 this time, over 2. Okay, and that is going to equal 2 root 3. You pair these two up and pull them out. So 2 times 2 is 4. The square root of 4 is 2. 2 comes out right there. And 3 over 2. These two cancel. And that gives you root 3. Okay. And so the answer to this up here is, remember there's a minus sign part of it too. The same thing except with a minus sign in front. So the two roots are going to be root 3 and minus negative root 3. I'm going to go to a separate piece of paper to do the irrational because I'll run out of paper here. So that's something you want to be careful if you choose to print these out. It may not be as much space as you need. Alright, so I'm going to, now we're going to factor this. We just finished factoring this. Now we're going to factor this. Alright, so we're going to treat this as x squared plus 0x, because it does not have an x term, plus 6. Okay, so there are our a, b, and c terms. Okay, I'm going to come up. Now I've already written the quadratic formula once. You don't need to write it a second time here. So it's going to be -0 plus or minus, but I'm going to just use the plus this time, so I'll take that off. And then just stick the minus sign on at the end when you're done with the calculation one time. Square root of 0 squared minus 4. A is 1. Whoops. Sorry, A is 1. We're down here on these numbers. A is 1. And C is 6. Okay, now you can see that -4 times 1 times 6 is going to be a negative number. It means we're going to have a negative number inside of a square root. That's going to make it an imaginary number. Alright, and that's all over 2 times A, which is 2. So we simplify this and we have radical 4 times 6 is 24, -24 over 2. Now we got to prime factor this out. So that's going to be the square root of 2 Okay, 2 times 2 times 2, and then I'm going to call this number the negative number. So now I pair up and pull out. I pair these two up and pull them out, so that brings a 2 outside. So it's 2. And then that's going to leave inside 2 times -3. That is the funniest looking 3 I've ever seen. Alright, and this is going to equal, I'm just simplifying it one step at a time, 2 times the square root of 2 times the square root of -3. Okay, again, you can break those. We did that in the very first part of this lesson. And this can simply further be, and as you get good at these, you'll do several of these steps at one time. It won't seem like it's so many steps, but be careful when you do that. So this is going to be 2 times the square root of 2 That stays the same. This is going to be the square root of 3, remember what I did before, times the square root of negative 1. Okay, negative 1 times 3 is negative 3, so I can break it into two different square roots there. And of course, we know that this is equal to I. Okay, so what I'm going to do then is, I have the 2 on the outside. I have a square root of 2, a square root of 3. I can put those back together again. I didn't have to pull them apart. So I have a square root of 6. I can't simplify that any further. So I have a square root of 6. And then I have this I. And remember, you put the I in front of the radical, not back here, otherwise it might look like it's inside. So what you end up with is 2I root 6. That's as simplified as it can be. However, there is, I neglected this 2 up here, so there is a 2 there. And that's going to cancel. And so really the simplified form is now I root 6. Okay? So that's this whole thing. That's only the positive sign, the plus sign. Well, actually up here, the plus sign of the plus or minus. Now I'm going to do it with a negative. So basically your two roots are this. It's going to be I root 6 and negative I root 6. And remember, when you write a complex number, if there's no real component, you put a 0 there. So the two roots are going to be this. 0 plus this. And 0 minus this. And then you had originally had a root back here. You had two roots back here. You had this and this. Now, those are real numbers, so you don't have to put a 0 plus, 0 minus on front of these. They're actually real numbers. Here you have a complex number, so you have a real part and an imaginary part. But here you just have real numbers. So I'm going to take these two here and put them in the front here. Okay, and there they are. Those are the roots. And you could even, if you want to simplify this, you could make this negative 3. Square root of 3 is 3, and there's a negative sign in front of it. So that you got that. I would consider that acceptable as an answer. Okay, so there is your final answer for that whole thing, okay? Or I would take this as well. Okay, again, these... Alright, so I wanted to make this short change so that it was clear what the answer to this question is. It is x plus, these are zeros. They're not roots, and you're supposed to write the roots. So this is x plus the square root of 3, x minus the square root of 3, and then the last two are fine. It's 0 plus I root 6, and 0 minus I root 6, and that's the final answer, not this. No, you can't take those and multiply them to do that. That was stated incorrectly. Okay, so that is what the final answer should be. Again, the difference is these two are zeros. They are the things that make these go to 0. Okay, the actual roots have an x value in them like that. Okay, so that's the corrected final answer. This is to problem number 4. All right. Things you have to practice. You can't just watch me do it once and expect that you know how to do this. And you should do it over and over until you get it right without looking at the solutions video. All right, that's key. It just sometimes this just takes time to learn these things. All right, let's move on. We're going to move on to number 5. And that is right here. Okay. So they decided to get really creative with these. So what you have to recognize is if you divided all these exponents by 2, you would have 3, 2, 1, and then a constant. All right, so that would make it a cubic. And if you're starting to recognize this pattern, what's that pattern we're kind of looking for? 2 over 1 and 8 over 4, which if you reduce it becomes 2 over 1. Okay, so you can use the grouping, in other words. So that is a 1 right there. So we're going to group this, and we're going to group this. It's always a little tricky with that minus sign out. You have to be careful with that. So let's start with this one. They don't have a number in common. There's a 1 and a 2. They don't have any number you could factor out. They have an x to the 6th, x to the 4th. So clearly they both have x to the 4th in common. Times what gives you x to the 6th? That would be x squared. And then here you pulled out the x to the 4th, so what gives you the negative 2? It would be negative 2. So again, x to the 4th times x squared is x to the 6th. X to the 4th times negative 2 is negative 2x to the 4th. So this is a difference that you can get a real number answer out of, but this is not a perfect square like a 4 or a 9, so you can't get a nice integer value. You're going to have to deal with some kind of a root value for that, but it is a real number. Okay, again, don't get rational numbers are real numbers. It will be an irrational number, meaning it will go on forever. The square root of 3 goes on forever. The square root of 2 goes on forever. Square root of 2 is 1.41, and on and on and on and on. That is an irrational number, but it's a real number. It's not. That's different from an imaginary number, which can't exist in the real world. So remember, there really aren't parentheses up here, so I'm going to write it the way it was originally, which is negative 4x squared plus 8. And now what I'm going to do is surround this whole thing with parentheses. And I'm going to factor out the negative 4. And that leaves an x squared in here. So negative 4 times x squared is negative 4x squared. And then it leaves a negative 2 over here. So negative 4 times negative 2 is positive 8. Okay, so this one is going to be x squared minus 2. All right, so now what you have, I can write this part down here. Okay, and you can see that we have that common factor that we're going to put the big square brackets around. And the x squared minus 2 comes out. So that's going to be in the curved parentheses. And then what you have left in the block parentheses is x to the 4th minus 4. Okay, now these are both going to be real numbers. There's no imaginary numbers here. It says there's 6 roots. It says find all 6 roots. There are 2 double roots. Okay, that's fine. So, but it doesn't say there's any imaginary roots, and there aren't. How do you know that? Because there is a number that when you square it will give you a positive number, and that positive number minus 2 will give you 0. There is such a number. There is such a number that when you multiply it to the 4th power, and that could be a negative or positive number, but when you multiply it to the 4th, you're definitely going to get a positive number. Anytime you have an even number exponent, it's going to give you a positive number as the final answer. So you have a positive number, so positive minus this negative number will get you to 0. So these are real numbers. All right, so let's do this one. We'll do this using the quadratic. So this one's going to be right here. We're going to write out the formula. Okay, we're going to identify A, B, and C. So A equals 1. That's the coefficient here. We don't have an x term, so that means B equals 0. And C equals negative 2. Okay, so let's plug in the numbers. I'll just use the plus part of this plus or minus. So again, something you want to learn to spot as you gain experience. A negative times a negative is going to be a positive. So you're going to have a positive number under the root sign. That means it's going to be a real number. There is a real number that's a positive square root. It's going to be a decimal number, but it's still a real number. All right, so what we have here, and then we have all that over 2a, which is 2. So negative 4 times negative 2 is positive 8. So what you have here is root 8 over 2. and that equals root of 2 times 2 times 2 over 2. And that equals, we can pair these two up and pull them out to a 2. So that equals 2 root 2 over 2. And I'm off screen, sorry. Okay, so I paired those up and pulled them out there. That leaves S2 behind inside the radical sign. And then I have this 2 on the bottom. So these two cancel, and that equals the square root of 2. And come back up and just use your common sense on this equation. The square root of 2 squared is 2. And 2 minus 2 is 0. So that is a 0. And now it could also be minus root 2. So actually both answers are plus. I'll just write the plus to emphasize it's positive. And minus root 2. So those are the two roots, okay? So the actual roots then, those are actually the zeros. The two roots are then going to be x plus root 2. This is a difference. You can treat this like a difference of squares. X minus root 2. Okay, so again, what makes that go to 0? Negative square root of 2. What makes that go to 0? This term over here, positive square root of 2. These two numbers right here. Let's FOIL it just to prove it. X times x is x squared. X times negative root 2 is negative root 2 x. X times positive root 2 is root 2x. And square root of 2 times negative square root of 2 is negative 2. Square root of 2 is 2, and then you got the negative sign, negative 2. These two cancel out, 2x and minus 2x. So you have x squared minus 2. That's what you have right there, x squared minus 2. So we've taken care of this one. Now we're going to take care of this one. All right? Now I tell you what, this is a perfect square. And if you recognize that the square root of this is 2 and the square root of this is x squared, then you can factor this the way we've been doing it. Okay? We know it's a difference of squares, so we're going to say x squared plus 2, x squared minus 2. Let's just save ourselves some work, okay? We don't have to use the quadratic formula. You may not recognize that right away, but again, with experience you will. And if you do, that's fine. It's just going to take more writing. So let's FOIL this out and see if these are actually factors. X squared times x squared is x to the 4th. X squared times negative 2 is negative 2x squared. X2 times x squared is positive 2x squared, so those are going to cancel. And 2 times negative 2 is negative 4. These cancel, and you end up with that, x to the 4th minus 4. So really, we're done. All right? But you can further factor these out. Well, what we saw already up here is that x squared minus 2 is going to be this down here. Shoot, I'm off screen. Is going to be this down here. So let me say that again. Okay, factoring this, just simple, we could just see difference of squares is this. All right. So this, we've seen this before. It was over here, right there. And we factored it out, and we ended up with that down there. So we already have those two factors. We're going to have those two factors again. Those are real numbers. And then, so we're going to have them once for this x squared minus 2. There they are. Then we're going to have them a second time for this x squared minus 2. So we don't have to do that calculation again. We've already done it. The only thing we need to do is this one. And again, this is a situation where no number squared plus 2 will equal 0. There's no real number zeros for x. Any number that I square is going to be a positive number. Positive number plus 2 can never be 0, can never be equal to 0. It's always going to be a positive number. So we need to use the quadratic formula for this, okay? Anytime you're dealing with an imaginary or complex number, you have to do the quadratic formula. So I've already written it once over there, so I don't have to write it again. So here we go. Let's just identify A, B, and C. Okay. So A is on this. Let's write, let me just draw a line under this. It's x squared plus 0x, because there's no x term there, plus 2. So A is 1, B is 0, and C is 2. So something you can recognize anytime you have any kind of quadratic you're trying to factor. If this is a positive number, this coefficient of x squared is a positive number, and the C number is a positive number, it's going to be irrational. You're just going to see that. You'll start to learn those little patterns like that. So let's plug it in. So it's going to be minus b. I'm just going to do the plus part of it. And it's over 2a, which is 2 times 1, so we'll just call that 2. Okay, again, you have a negative number inside here. You see that's going to happen. So that's going to be two. Okay, and I'm going to break that into this. Okay, it's going to have one of them's going to have to be negative to make that negative. Okay, I'm going to pair these up and pull them out. So I end up with 2 root negative 2 over 2. Now I can go ahead right now and cancel these 2's. So this is going to equal, we can break this up into the square root of 2 times the square root of negative 1. 2 times negative 1 is negative 2. Of course, we know that equals I. So that means it's going to be root 2 with an I in the front. Put the I in the front. And then you have another one using the negative part of the quadratic. When the quadratic is always a plus, and then you go back and do the minus. So we've done the plus, so now the minus is just flip the sign there. Okay, so those are the zeros. Now remember, let's see, this one was, okay, so this one is x squared plus 2. So your roots are actually going to be, these are called the zeros. I root 2 and negative I root 2. So the roots are actually x plus I root 2 and x minus I root 2. Okay, wowza. So how many roots do we have? We have 1, 2 from this guy. Then we came over here with this guy and it became just a real zoo. We factored this into this, and now we have those same 2 roots. There's that same expression. There it was, x squared minus 2, there it is again. So we have those same 2 roots a second time. And then for this one, we used the quadratic formula and we came up with these 2 roots. So I'm going to write them all. I don't think I can fit them all on the same line, but I'm going to give it a shot. It's going to be x plus root 2, x minus root 2. Okay, and that came from this guy over here, and that's what I have down here. Now, we have that same term, x squared minus 2, so I'm going to have these 2 roots again. And it said, notice it said up here in the instruction, there are 2 double roots. These are the double roots. Okay, I'm going to write them separately though. So it's x plus root 2, x minus root 2, and then finally these, which came from this guy right here. So let's see if I can fit them all in the same line. I don't think I can. X plus I root 2 and x, this one, minus I root 2. What do you know? I just barely did it. So the total of, it said, find all 6 roots. 2 of them are double. So there's 1, 2, 3, 4, 5, 6 roots. Okay, this is a killer problem, but I'll tell you something. If you're willing to practice this one a few times, if you can do this problem, you can do any problem we've done this week. Seriously. So sometimes that was kind of my strategy in math. Learn to do the hardest problem. And then if I can do the hardest problem, I can do all the others. Okay? So that is actually your final answer down there. All right? Again, if you can't read that, there's part of it. and there's the other part of it. There's the other part of it right there, and you do those twice. Okay, that was a lot. It's going to make your brain burn a little bit, but the way to do this, the way I would do this, is I went back and I just wrote this on a separate piece of paper, not even what I was going to turn in, and I practiced it. And I said, do I know where to start? And if I didn't even know where to start, I just, okay, I'll cheat a little, uncover. Oh yeah, it's grouping. Okay, so we grouped. We came up with x squared minus 2. Again, this one's a little tricky over here with that minus sign out there. It's x squared minus 2 factored out of the square brackets. Inside, you left x to the 4th minus 4. Okay, so x squared minus 2 is a real number. It's not a perfect square, but it's going to be a binomial real number, x plus something, x minus something. And it turns out it's x plus the square root of 2, x minus the square root of 2. Use the quadratic formula for that. All right, then we took this part by itself and came up here, and you saw that that's a difference of squares. That's a perfect square of x squared. That's a perfect square of 2. So we just used that property to factor that very simply. X squared plus 2, x squared minus 2. If you FOIL it out, you'll find out it gets you back to that. Okay, that's what I did right here. That was just a check to prove that. Okay, so now we already have done this down here. We didn't need to do it a second time. Okay, there we did it. So we have it again. So we know those two roots are going to come up again. Then this one, you guys just have to identify your A, B, and C. A is 1. There is no x term, so B is 0. And then C is 2. And then you plug into the quadratic formula. And you got to use these principles of exponents. Pair up and pull out. The fact that you can break the square root of negative 2 into the square root of 2 and square root of negative 1, and that is I. So that's a real number now, and that's I. And you could pair up, pull out, cancel those 2's. So again, just some of those principles we worked out on the first page are all there. Okay, I would practice this one a lot. I mean, get serious about this, and you can understand it, I promise you. Once upon a time, I didn't think I could, but I realized I wasn't working hard enough. I had to go through and just keep writing this out over and over and over again until it finally stuck. Okay, and that's the deal. That is the deal in math. Okay, that's it for this one. This is the end of the 2.05. I'm going to get 2.06 up this weekend. We'll get into that on Monday, but if you want to get started on that, you can. And I will see you on the next video or see you in class.